Okay, so you picked up 3 things when you came in the door. A pink piece of cardstock, a pink piece of paper, and a green piece of paper, right? On the green piece of paper, put page 108 at the top, okay? And I know that's kind of out of order, but then the pink piece of paper, the paper one, you're going to take some scissors and you're going to cut in that space. It's not really in half, but just cut it in 2 pieces that's almost in half. And this goes on page 109 and 110 in your ISN, and they should be side-by-side pages. So go ahead and cut it and put that in there right now. It is the same stuff that's on the pink cardstock. It's spaced a little bit differently because I wanted you to be able to cut it, but it's the same stuff. So you're going to have this in your ISN, and then the cardstock is just for you to keep in your binder that's maybe a little bit easier reference than you flipping back and forth in your ISN, okay? So you just have it in 2 places. While you're doing that, I want to talk a little bit. I'm going to give you kind of something that seems totally off topic to kind of move into what we're doing today. We've talked a little bit about percentages before and just kind of life skill. Like you should know how to very easily find 10% of something, right? So what's 10% of 50? $5. If I know that, then I can easily find 40% of 50, right? Because I can just multiply that 5 times 4, right? So that'd be 20 bucks. Make sense? Like that's pretty easy to do. If I want 32% of 50, I could estimate it, but if I wanted like the actual percentage, I'd have to do a little bit more work, right? But not necessarily. Here I want you to show you something because I will be real honest with you. I've been teaching way longer than y'all have been alive. And I have a degree in math, took tons of math in college, been teaching it forever. And this kind of blew my mind the other day because I never really thought about it, but it's so true. And I don't know how it never like occurred to me before. Did you know that 32% of 20 is the same as 20% of 32? And one of them is a whole lot easier to do, right? Like what is 20% of 32? Which is 6.4. So it's $6.40, right? I mean, if we're talking money. So that's easier than the 32% of 20. So let me show you the why behind this, okay? Because like, does this work every time? I don't know. You don't even know if it works on this one because you probably don't want to figure out what 32% of 20 is, right? So when we do this mathematically, percentages, what do we normally turn them into? Like decimals, okay? So 0.32 times 20 equals 0.20 times 32. Like I want to see if that's true or not. Huh? No, I did not discover it. It was some random Facebook post when it said that. I was like, what? And it kind of blew my mind. I thought, wow, that's kind of interesting. But it will be very helpful, and I'll show you why you're interested. Just like as a life skill too. Okay, so we can do percentages as decimals, but we can also write them as what? Fractions. That's how you actually first learn them. So 32 over 100 times 20 equals 20 over 100, and I do not want to reduce any of this at this point, like this, right? Now I can factor 1 over 100 times 32 times 20 equals 1 over 100 times 20 times 32. So that is a true statement, and that's basically the why behind it. But that doesn't prove anything. That just shows that it works for these two numbers. If it does work that way, then what is 32% of 50? 50% of 32 is 16, right? See how easy that is? 32% of 50 is the same as 50% of 32, so that's $16. See how easy that is? Now, again, this doesn't prove anything. This just shows, and again, maybe that isn't true for 50 because we just said it worked because of this one. When you truly want to prove it, you have to use variables, right? And show that it works every time. So here's what basically a little proof looks like. X% of y is the same as y% of x. And if we say x and y are all real numbers, then it'll work for everything, right? So x%, we'll do x over 100 times y equals y over 100 times x. And then even like right now, if you're like, oh yeah, I see that it works, if you're supposed to be verifying or showing that, you still have to go through the steps. So this is 1 over 100 times x times y equals 1 over 100 times y times x. Now, we can also see right now that, yeah, those are going to be the same thing, right? But do they look identical? No, they don't, right? They're not exactly the same, and if I'm doing a proof, they got to be exactly the same. That's easy to do, right? I can switch these around. Anybody know what the property is called that allows you to multiply in any order? Starts with a C. No. Okay, let me write it down. Okay, so we know that this is legal, right? We just may not know the why. The why is called the commutative property. There's the commutative, the associative, the distributive. You learned all those when you first learned them. It was like elementary school. But to remember the difference between commutative and associative, because those are the ones that get mixed up the most, this got to commute from here to here. That's one way to look at it. Associative is this one, A plus B plus C equals A plus B plus C. Associative is like this. Basically, you can associate these two together or you can associate those two together, and it's the same thing. So that's the associative property. This is the commutative property. I'm not going to test you over it, but it's still something you should know. Okay, so this is your little bit of life lesson today that X% of Y is the same as Y% of X. But this whole proof part that we're doing right here is kind of similar to what we're going to be doing with trig identities. Kind of, but not really, but they're not really like the proofs you did in geometry either. But it's along the same ways. Basically, most of the time, I'm going to give you the answer. Here's the answer. You have to show me how to legally get there, okay? So basically, we knew what our goal was. Our goal was to show that they're the same, and we got there, okay? So with all that said, keep your pink cardstock handy, and the paper can already be in your ISN, and then let's write on the green one, okay? So this, what I said, it's going on page 108. Oops. What the heck? Okay, there we go. All right, so trig identities. A trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression in the equation is defined. Okay, so it's something that's always true. The identities help evaluate functions, simplify expressions, verify identities, and solve equations. Now, these basic ones right here, you already know this stuff. We just didn't call them identities, okay? The tangent theta is sine over cosine. You already knew that. A cotangent is cosine over sine. Old news, right? All of our reciprocals, all that is old news too, yes? So you kind of already know them. Do you have to memorize all of these? No. But if you don't know these already, I don't know how you've gotten this far, okay, basically. So like, you shouldn't have to look at these on the chart, but they're there, okay? So let's look at how we're going to use these. In a way, we've kind of already done some of this stuff. We just, again, didn't call them identities. So it says use the quotient and reciprocal identities to find each function value. So it says if secant theta is negative square root of 30 over 3, find cosine theta. Well, what is the reciprocal of secant? Cosine. So that means that cosine theta is just equal to negative 3 over the square root of 30. Can I leave it like that? No. So this becomes negative 3 square root of 30 over what? 30, which means in the end cosine theta equals negative what? Square root of 30 over 10. Okay? And you could have done that without me giving you any information today. You could have figured that out on your own, right? Like you could handle that. All right, so let's look at number 2. It says if tangent of x is the square root of 2 over 4 and cosine of x is negative 2 square root of 2 over 3, find the sine of x. All right, so what we know that the tangent of x is equal to the sine of x over the cosine of x. Okay, so I can just substitute. Tangent of x is square root of 2 over 4. That's equal to, the numerator would be sine, which I don't know. Denominator is cosine, which is negative 2 square root of 2 over 3. Now I got to get sine of x by itself, so I can just multiply both sides by the denominator. So I get negative 2 square root of 2 over 3 times the square root of 2 over 4 is equal to the sine of x. What's the square root of 2 times the square root of 2? 2 times 2 is 4, so those cancel that 4 out. So that means that the sine of x is equal to what? Negative 1/3. Okay. Everybody okay with that? Okay. Just manipulating what you have to get to the end result of whatever it is you're looking for. All right. So then it says if cosecant of beta is 7/3 and cotangent beta is negative 2 square root of 10 over 3, we want to find secant. Okay. So cotangent is a quotient, so I can say that I know that the cotangent of beta is cosine beta over sine beta. Right? But we're talking in terms of cosecant and secant, right? But the reciprocal of secant is what? Cosine. So if I can find cosine, I can find secant. And the reciprocal of cosecant is what? Sine. So the sine of beta equals 3 over 7. Now just as a little side note here, when I took that reciprocal, if that 7 had been a square root of 7, I would not bother rationalizing right now. No need to do that because, I mean, it's not wrong, but you're probably just making your numbers bigger. Don't wait, just substitute it in. It might cancel out anyway, and then you can just do it all in the end. Does that make sense? Like you don't have to do it in the middle of something. You can do it at the end. All right, so now that I have all of that, I can substitute. So the cotangent is negative 2 square root of 10 over 3. That's equal to the cosine, which I don't know, over the sine, which is 3/7. So then I multiply both sides, so I get negative 2 square root of 10 over 3 times 3 over 7 equals cosine of beta. So that means that negative 2 square root of 10 over 7 equals cosine. But I don't want the cosine, right? I want the secant. So secant of beta equals negative 7 over 2 square root of 10, which means that, negative 7 square root of 10 over what? 20. Okay. Do y'all see now one of the many, many reasons I make such a huge deal about understanding your fractions and square roots? Because for most of you, you don't even give it a second thought anymore. It doesn't freak you out because you finally get them and you're not afraid of them. You're not trying to avoid them anymore. All right, we all good so far? All right, so that is your reciprocal and quotient identities. Now we have some Pythagorean identities. So let's talk about why they're even called that. So if I draw a triangle in the unit circle, okay, so this is a unit circle, then what is the length of the hypotenuse? 1. So since it's a unit circle, that's my radius. What does this side represent? Cosine theta. And this represents sine theta, right? So what we know about the Pythagorean theorem is that a squared plus b squared equals c squared. Well, cosine squared plus sine squared equals 1. And that's what this one is right here. Make sense? And the other ones kind of come from some version of that, just like that. One thing you need to understand about trig functions when you square them, what it looks like, how you say it, what it means, is that if I take cosine theta, whatever it is, and I square it, that is cosine squared theta. Like that's how you say it. That's how you write it. You don't ever write it like that and it's not cosine theta squared. Does that make sense to you? So if cosine theta is 3/4, then cosine squared theta is 9/16. Like you square it. So it just kind of looks a little different than the way you might think about it. Right, exactly. You wouldn't square the angle measure. Yeah, and it's not, because it's not like a distributive thing or whatever. Okay. So it says to use these Pythagorean identities, and it says find cosine theta and tangent theta, 2 parts of the question, if sine theta is negative 1/3 and cotangent theta is less than 0. So the first thing you have to do is decide which quadrant you're in, because this is going to determine whether your answers are positive or negative. So here's what we know. We know that the sine value is negative. So sine is negative in which quadrants? 3rd and 4th. We also know that cotangent is negative, and that's in which quadrants? 2 and 4, which means I have to be in which quadrant? 4. So I'm in quadrant 4, and that's going to determine, again, whether my answers are positive or negative, depending on which ones which trig function I'm using. Okay, so I'm going to find cosine theta. I want to find cosine theta first. I know sine theta, so I'm going to use this one. So that means that cosine squared theta plus sine is negative 1/3 squared equals 1. So cosine squared theta plus 1/9 equals 1. So what does cosine squared theta equal? 8/9. So then I take the square root of both sides. When I do that, I get cosine theta. The denominator will just be 3. What's the numerator going to be? 2 square root of 2. Okay, but I took the square root of both sides, so technically my answer is plus or minus. Is this answer going to be positive or negative? Positive, because cosine is positive in the fourth quadrant. That's why that quadrant matters. So that tells me that that has to be positive. We all okay with that? Okay, so now I need to find tangent. I have options. A lot of times when you're using identities, you have options. So let's talk about some of the options, and then we'll talk about how I'm going to make us do it right now. I want tangent. Well, I know tangent is sine over cosine. So I could use this over this, and then I could just simplify. Nothing wrong with that. I could also use one of the Pythagorean identities, which is actually what we're going to do because I want to make sure that we have some more practice with that. And we get the same answer either way. But the problem is that I have cosine and sine, and they go together. Tangent is over here with secant. Well, secant is the reciprocal of cosine. So I could take the reciprocal of this one and then use it to help me find tangent. But you never want to use what they gave you unless you have to, because what if we messed it up, right? So I could use what they gave me. What they gave me is sine. The reciprocal of sine is cosecant, and that would be -3. So if I use cosecant, I can use it to find cotangent, and then if I have cotangent, can I find tangent? Yes? Okay, so that's what we're going to do. So using this one, cotangent, which is what I'm looking for, cotangent squared theta plus 1 equals -3 squared. So cotangent squared theta equals, well, that's going to be 9 minus 1, which is 8, right? So then that means that cotangent theta is what? 2 square root of 2. Not my final answer, though. Tangent theta is 1 over, oh, is that positive or negative? Negative, because I'm in quadrant 4. I almost forgot that because I took the square root. So this is actually negative 1 over 2 square root of 2. When I rationalize, I get negative what? Square root of 2 over 4. Yes? Okay. All right, what questions do you have at this point? Okay, so let's look at number 5. It says find the tangent of x and the sine of x if secant is 6/5 and sine is greater than 0. So the first thing we do is think about our quadrants. Secant is the reciprocal of what? Cosine, and cosine is positive in quadrants 1 and 4. Sine is positive, sine's positive in 1 and 2, so we're all in the first quadrant, which means everything's positive. Okay. All right, so I have secant. Secant will get me tangent, which is the first thing that I want, so we'll go with that. So I'm going to use this one right here. Right. So tangent squared theta plus 1 equals 6/5 squared. So tangent squared theta plus 1 equals 36 over 25. So tangent squared theta equals what? 11 over 25. Good. So when I take the square root of both sides, I get that the tangent of theta equals the square root of 11 over 5, and it's positive because we're in the first quadrant. Okay? Everybody okay with that? All right, so then secant, the reciprocal of secant is cosine. So the cosine of x is 5 over 6. And I also need the sine here. So I can use that first Pythagorean identity, which says that cosine squared, so that's 5/6 squared, plus sine squared, which I don't know, equals 1. So it's 25 over 36 plus sine squared x equals 1. So what does sine squared x equal? 11 over 36, which means that the sine of x is equal to the square root of 11 over 6. Again, it's positive because we're in the first quadrant. Okay, we okay with that? What questions do we have? All right. So let's look at the cofunction and even and odd identities. Okay, and again, you're not memorizing these. You just have to be able to find them and use them and understand how to use them. But let's talk about what these even mean. We'll just talk about sine and cosine, basically. So this says the sine of theta is equal to the cosine of pi halves minus theta. So what is theta, or what's pi halves in degrees? 90. So that means that the sine of theta is equal to the cosine of the complementary angle, right? Makes sense? So if I have a right triangle, this is my theta, right? So this is opposite, this is adjacent, this is hypotenuse. So the sine of theta is going to be opposite over hypotenuse, right? The cosine, 90 minus theta is this angle right here, right? The cosine of that angle is this side over this side. So you see how they're the same? That's why they're called cofunctions. So they're the same. So that's what's happening with these. You're going to get the same value whether you, like if I just take pi halves and subtract theta and take the cosine, it's the same as the sine. Okay? That's what all of those mean in their different versions of them. Then we have even and odd identities. Okay? So see how we have sine of negative theta equals negative sine of theta. Here is what is not happening. And I can't stress this enough because otherwise you're going to get yourself confused and stuff. You are not factoring out this negative to get it here because you can't do that. That's not legal. This isn't multiplication, so you can't just pull the negative out of the little parentheses, okay? What this is saying though, like for instance, let's think about, or here, let's look at the next one, which is cosine. So cosine of negative theta equals cosine of theta. See, I didn't factor it out and it doesn't just disappear. But let's just think about pi fourths, right? So what's the sine of negative pi fourths? Negative square root of 2 over 2. We agree with that? Then the sine, just the sine of pi fourths is square root of 2 over 2, but when I put the negative sign in it, now it's negative square root of 2 over 2. Make sense? When I do that for cosine, what's the cosine of negative square root of 2 over 2? I'm sorry. What's the cosine? Oh, goodness. Siri's talking to me. Okay. What is the, let me rephrase that, because what is the cosine of negative pi fourths? Is what I'm, square root of 2 over 2. And it's positive, right? Because cosine's positive in the fourth quadrant. That's why this says just cosine of theta. Okay? That's why they're not all the same. There's no factoring. Parker, sit up, or you're going to be all kinds of lost on this bottom part. Okay? Are we good? So just make sure that you can find them up here and understand that if all it was you factoring it out, there would be no purpose of even having them up there, right? Okay, so it says use the cofunction and even and odd identities to find each value. So it says the sine of negative theta equals negative 0.97. And then it also tells me, well, it tells me I want to find the cosine of pi halves minus theta. Well, the cosine of pi halves minus theta equals sine. Yes? So if I can figure out what sine is, I'm good. So I'm going to go down here. I know from this right here that the sine of negative theta equals negative sine theta. We agree with that? Now I'm going to substitute. This negative 0.97, I'm going to substitute right here because these two things are equal. So I get negative 0.97 equals negative sine theta. So that means that 0.97 equals sine theta. Now when I look up here, I'm going to write this thing down. Sine theta is equal to the cosine of pi halves minus theta. And then I know what sine theta is, so 0.97 equals the cosine of pi halves minus theta. Okay? What questions do you have? That's your answer because it says to find this. I found it. Just by a bunch of substitution. Huh? Absolutely, 100%. Okay? We good with that? So you have to understand what to substitute and do it legally. All right? Well, for like the 5th time today, you will be given that. You don't have to memorize them. You have to know how to find them and know how to use them. Okay. So now, let's look at number 7. If the tangent of negative alpha is equal to negative 2.36, we want to find the cotangent of alpha minus pi halves. So can you even find this up here? No. There's something that kind of looks like it, but it's not the same, right? What's different about it? The other way, right? This is pi halves minus the angle. This is the angle minus pi halves. Those are absolutely not the same thing. But if you subtract in the opposite direction, what's the only thing that really happens to your answer? The sign changes. 3 minus 4 versus 4 minus 3, it's the same number, it's just whether it's positive or negative, right? So if I want to switch those around, because like I'm going to need to fix this so it matches something up here, right? I can do that by factoring out a -1, right? So I cannot stress to you enough, you need to stay with me on this and make sure that you are thinking about each and every step. You cannot skip steps on this. You can't, or you're going to get lost and confused in this. It is not that difficult. You just have to understand where everything is coming from. All right, so here's what I'm going to do. We're going to take this right here, and I'm going to write, I'm just writing this down. Cotangent of alpha minus pi halves. So I cannot change the value of it, but I need to flip things around, right? So this is going to be equal to the cotangent of negative pi halves minus alpha. Do you see how I just factored out a -1 inside of that little thing? We all good so far? Every time I have to switch them around, yes. Then I have to decide what happens with this. So I'm going to write down my left-hand side again, cotangent of alpha minus pi halves. Okay, so basically this in here, this pi halves minus alpha, this is just some angle measure, right? So I can think of this as cotangent of negative theta. So the cotangent of negative theta equals negative cotangent of theta, right? That means that this just equals negative cotangent of pi halves minus alpha. I did not factor it all the way out to the front because that's not legal. It's from the identities up there. Okay, we all good so far? All right, so that's negative cotangent of pi halves minus alpha. So I know that tangent of negative alpha equals negative 2.36, right? Well, actually, let me take this one more step. What does just cotangent, can I find this part, not the negative, but this part up there? Cotangent of pi halves minus alpha equals what? Tangent. Okay, so since this is negative cotangent, this is going to be negative tangent of alpha equals negative cotangent of pi halves minus alpha. Oh, wait, I'm sorry. I'm sorry. I did that wrong. Oh, back up. I lied. Hang on. Yeah, I know. I messed up. Sorry. I meant to substitute. Okay. I meant to rewrite this part right here. Cotangent of alpha minus pi halves equals, okay, so instead of negative cotangent of this, I now have negative tangent of alpha. That's what I meant to do. I meant to replace it because we just said that they were the same thing. You with me? Sorry, I wrote down the wrong thing. You're lying to me, right? Okay. All right. So I have tangent of negative alpha. I'm going to rewrite this over here. So tangent of negative alpha. This is just what they gave me. I'm just rewriting it so you can see where it is. Okay, what does the tangent of negative alpha equal? Negative tangent of alpha. So negative tangent alpha equals negative 2.36. Now, do I really care what tangent of alpha is? No, because I need negative tangent of alpha. So my answer, cotangent of alpha minus pi halves equals negative 2.36. That is my answer. This, okay, I just wrote this down, and because of this up here, because of this right here. Okay, what questions do you have? Here, what I did, and when I messed up, I wrote the wrong thing down. When we had this negative cotangent of pi halves minus alpha, well, cotangent of pi halves minus alpha is tangent. So if this is negative, and that's why I just substituted that. That's where that came from. It's asking me to find this. And so then, I mean, that's what it's asking. It's asking me to find this. So I have to manipulate what I have until I can make this equal what I want. So this is what I'm looking for, and I know that it's equal to this, and then I just manipulate this using my identities. Okay? Well, you could. I could have done this first. I could have. I totally could have. And before, sometimes what I did, and there's nothing wrong with that. Well, you could start with this, but even if you start with this, you still have to go over here. Like Well, not really in reverse, because even if I did this first, I would still then have to go to this next. I wouldn't be able to go up. Yeah, every time. But if you want to write that down as another identity, yeah, but there's not going to be an infinite amount of different things you can write like that. Like, you don't want to write everything down. The whole point is we have these so we can figure everything else out. Okay? Yeah. All right, so let's do number 8. No, you cannot opt out. All right, so if secant of beta minus pi halves equals negative 3.62, find the cosecant of negative beta. Okay? No. No, tangent of negative alpha equals the cotangent of alpha minus pi halves, but tangent and cotangent do not equal each other, no. No, not necessarily. Well, the answer, it could be negative 3.62, or it could be positive 3.62, or it could be something else, but you don't know until we go through all of this. Trust me. Let's do this one. So this is the secant of beta minus pi halves. So the first thing I need to do is flip around that so it's pi halves minus beta, right? Okay. So secant of beta minus pi halves, I know that to do that I can factor out, right? So secant of negative, and then that's pi halves minus beta, right? So I'm going to rewrite the left-hand side. Secant of beta minus pi halves equals. All right, so now this is basically secant of negative theta, right? What does secant of negative theta equal? Secant theta. So that means this is secant of pi halves minus beta. Because of the identities, not because I get to magically make a negative sign disappear. Okay, everybody understand where all that's coming from? Yes, because this is like secant of negative theta, and this is secant theta, and up there it says that they're equal to each other. Yes?
Okay, so in no, like, unless it's this, it's illegal to swap them, but can we just skip the first step now that we know that they all swap?
Yeah, that's fine. No, because secant of negative theta equals secant theta.
That threw me off. It's like with tangent,
Yeah.
it goes in front of the tangent.
Yeah, on this one, this one it comes out because cotangent of negative theta equals negative cotangent of theta. But secant of negative theta equals secant of theta. Okay? That's why you need to keep referring back to these and make sure you're using them legally. If you don't remember them, whatever, but you just need to be able to find it and substitute it correctly. That's the important part of it. Okay? We good so far? Yeah, maybe? Okay. All right. So now I'm going to substitute. You ready? Secant of beta minus pi halves equals this number. So I'm going to substitute it in right here. So negative 3.62 equals the secant of pi halves minus beta. Okay, I know, we're not done. Good job. Okay, now, what does this, from my identities, secant of pi halves minus beta, what does that equal? Well, look up. Don't look at me. Look up on your paper. No. Secant of pi halves minus theta equals cosecant theta. That. Well, now just hang on. Don't get ahead of yourself. We'll substitute one thing at a time. Okay, so negative 3.62 equals cosecant of, it's actually beta on this one. So now, that's not what I'm looking for. I'm looking for the cosecant of negative beta. So cosecant of negative beta equals negative cosecant of theta. So this is negative 3.62 equals negative cosecant. Oh, shoot. Sorry. Hang on a second. I messed that up again. I need to be able to substitute. Sorry, I don't know what's wrong with me today. I need this to be negative cosecant of beta in order to substitute, right? So I need to multiply through by a negative 1. 3.62 equals negative cosecant of beta. Do y'all agree that that's true from there? Okay. So then, because I just found this up here, I got ahead of myself again. Negative cosecant of theta equals cosecant of negative theta. So now I can substitute, and 3.62 equals cosecant of negative beta. Once you get into this and do it, I don't think that it's going to be as bad as you think. My suggestion to you is the people that got it the best last period, as soon as I gave them their assignment, they flipped it over on the back and did these first. And they talked themselves through it. Okay? So you talk yourself through it. This has to equal this because of this. Use your chart. The paper that you put in your ISN and this, both of these, you can write on them. You can do whatever you need to do to them. When you use them in class, I'll give you my copy so that you don't have to worry about your copy staying clean. But you can do this. This right here, honestly, is probably the most confusing part. It's really not that bad once you wrap your mind around it, but one of the most confusing parts of all of this identity stuff we're doing. So it's not great that we start with it because I think it kind of, freaks you out a little bit, but it'll get better, I promise. Okay? What questions do you have? Yeah, right now we only have part of it. Like, I've given you everything we're going to use, but yeah, we only have part of it right now. Okay? We good? All right.